All right, we have the pleasure of a remote participant, yes? So we're going to just put the microphone next to her? Okay. Oh, man, we could have gotten better technology for this.
I think this is going to work.
Okay. All right. Our federal participant, Kris Garber from the US EPA, is on this little device, amazing modern technology, combined with this modern technology. Is hopefully, Kris, if you say something.
Hello, everybody.
Okay, let's try. Okay. Okay, try again. Say hello again, please.
Hello.
Whoa, okay. Perfect. All right. You're on, ready to go. We're going to hear about risk assessment in pesticides, ecological risk assessment of pesticides. Please, Kris, take it away.
All right, here we go. So, first of all, sorry I couldn't join y'all in person, and we can have some Q&A later on, and in the future if other questions pop up, you're free to shoot me an email, and we can follow up later. But what I'm going to talk about now is what we do with the headquarters in EPA for assessing risks of pesticides. Okay, there we go. So I'm going to start out just giving you kind of an overview of the division and the kind of organization that works on these risk assessments, and I'll talk about some of the statutes and data requirements associated with pesticides to kind of orient everybody as to what data we work with and what are required of pesticide companies that register pesticide. And then I'll walk you through our risk assessment methodology, and then we'll talk about both kind of our kind of general risk assessments as well as endangered species. So, in the government, of course, we're always, there are lots of trees that define our organization. So I'm in at US EPA, and under that is the Office of Pesticide Programs. And within that, we have several different divisions. And my division is the Environmental Fate and Effects Division, and we're responsible for doing environmental risk assessments for pesticides. There are other divisions in OPP that do, for example, the Health Effects Division focuses on human health. There are other folks like Pesticide Reevaluation Division that they do the management of the risks. They make the decisions about kind of human health and ecological risks and whether those are unreasonable and need to result in some kind of change to the registration of the pesticide. So I'm going to focus on the Environmental Fate and Effects Division since we're the ones that do the ecological risk assessments. A lot of our time is spent on ecological risk assessments for the entire environment. A lot of our time lately has been spent on endangered and threatened species risk assessments. We've been working with the Fish and Wildlife Service and National Marine Fisheries Service to come up with a methodology for assessing the risks to all listed species, which is over 1,800 species, and so that's been a pretty large effort. We also do risk assess, we assess kind of the estimated concentrations of pesticides in water that may be consumed by humans for human health assessments. Kind of in the day-to-day, we do a lot of work with new active ingredients, new pesticides that are proposed for registration or new uses of existing pesticides. There's also a really large program called Registration Review that requires us to reevaluate the risks of pesticides every 15 years. And so we also go through reevaluations of existing pesticides on a regular basis. And then a large part of our work is reviewing data. We, as I'll talk a little bit more in a few minutes, we require a lot of data on the environmental fate and toxicity of a chemical, and when those data are submitted by pesticide companies, we review them in a pretty detailed process. There's a lot of peer review built into our work. Our assessments are all science-based, and so we have an internal peer review process where kind of senior scientists will review risk assessments or data evaluation records. And then we also have an external peer review process where we go to a science advisory panel with any new methodologies, or sometimes we'll go to that SAP for major risk assessments, and solicit their feedback on our methodology. A lot of our work also is developing new methods or developing policies related to simulation models, or when kind of there's an emerging issue like honeybees or bees in general. We've been spending a lot of time over the last 5 years developing a new risk assessment methodology to be able to effectively assess risk to bees. We also spend a lot of time collaborating with other groups, primarily in other government agencies. We collaborate with our federal partners at Fish and Wildlife, or USDA, or National Marine Fisheries Service, Forest Service. We also collaborate with other international groups in reviews of pesticides. So we work with the Canadian government frequently, and also folks in Europe as well. Okay. So statutes. So the laws that we operate under primarily are, the main one is called FIFRA, the Federal Insecticide, Fungicide, Rodenticide Act. It's a risk-benefit standard, and so we have to, in our decisions, consider the ecological risks as well as human health risks of the use of a pesticide, along with the benefit of that pesticide to growers in terms of controlling pesticide, or in terms of controlling pests. And so we do benefits analyses as part of our assessments, and we'll also assess the risks, or we'll assess the benefits of alternative pesticides as well. A major part of the human health assessment is the Federal Food, Drug, Cosmetic Act, and the Quality Protection Act. This is really changed the way we do risk assessments for human health a couple decades ago, which requires us to establish tolerances on food for pesticides. And we are involved in the environmental fate side in our drinking water assessments. So that's part of what goes into that particular meeting that standard. And then, of course, the Endangered Species Act is an important part of our work as well. So, coming into compliance with the Endangered Species Act in terms of the decisions to register pesticides has been a major focus of our division in the last several years. Right. Okay, so data requirements. FIFRA defines several data requirements of pesticide companies that want to register or support registrations of their active ingredients or of their products. And these are all well defined in the Code of Federal Regulations. There's a link there in case anybody wants to check out the details. But the data requirements define the chemistry of the products. So what are some very basic physical chemical properties, toxicology for human health assessments, a lot of mammalian data. We focus on is the ecological effects and environmental fate data that define exposure. There are sprayer studies, and then for other kind of non-conventional pesticides like biochemical or microbial or antimicrobial, there are a unique set of data requirements as well. So I'm focusing really more on conventional pesticides, since that's what we do in the environmental effects division. So conventional pesticides would include organophosphates or bitumen or nicotinoids or chemical herbicides, just to name a few classes. There are many more than that. Okay, so our test guidelines, all of the data that are required in the Code of Federal Regulations are standardized test methods, and all those methods are laid out and they're publicly available so that pesticide companies know what's expected of them in terms of how to conduct those studies, and then we are very clear at the EPA in terms of how we review those studies. So if they don't meet the kind of minimum requirements of those guidelines, then those data might be considered invalid, or they might be considered unacceptable for fulfilling a data requirement, and then we would require a pesticide company to submit a new study. And so, you know, they're diverse in terms of whether it's a fate study in a laboratory or a field study. Those are all defined. All right. So just to kind of get into a little bit more the ecological effects data that we require, and we use all these data in our risk assessments. They define toxicity testing for aquatic animals like fish and invertebrates like eastern oysters is one of the test species. We require data on acute and chronic toxicity. Usually the acute would focus on mortality as an endpoint, and then chronic would look at some kind of sublethal effect like growth or reproduction impairment. There are requirements for laboratory and field studies. Typically we focus more on the laboratory studies. Bioconcentration or bioaccumulation studies are part of that data set, and they would look at water columns and sediment as well. So that's in the aquatic world. When we're looking at terrestrial, we have data requirements for vertebrates like birds or wild mammals, again, acute chronic toxicity. Recently, we've been going through changes to the honeybee data requirements, and we're currently updating the Code of Federal Regulations to include toxicity data on adults and larvae, and then there are laboratory and field studies as well. One thing that's probably of interest to this group is that we've been requiring residue data for pollen and nectar in plants that have been treated with pesticides. So that's not currently in the Code of Federal Regulations, but we have other documents that point to that information. And the whole idea is to get a better understanding of what kind of exposure honeybees or other bees, other pollinators in general, might be exposed to when a chemical has been applied to a crop. Also, we require data on terrestrial and aquatic plants, for terrestrial, it's typically crop species, and then for aquatic plants, there are several different species that are tested. All right, I'm trying to go quickly, and so hopefully I'm not breezing through this too fast. On the fate side, we require several different studies that define basically the persistence or lack of persistence of a chemical under different potential mechanisms of degradation. So we look at their studies are designed to target photolysis or hydrolysis or microbial degradation under aerobic or anaerobic conditions. And then we also require field cetacean studies that would kind of let us know if the FATE studies in the lab are lining up with what actually happens in the field. And, we look for, in all those studies, we look for degradates, in particular degradates that might be of toxicological concern. Because often when a pesticide is degraded, the degradates will be of a comparable toxicity as the parent. There are a number of spray drift studies that are also in the guideline requirements. They might be conditionally required depending upon the use of the chemical or the label statement that are on a pesticide product. Okay, so I'm going to get into the risk assessment process that we go through. We separate out our risk assessments by taxa, and it's really related to the toxicity data we have as well as our models. And so we divide our assessments into terrestrial and aquatic. For terrestrial, we generally are looking at risks to birds or mammals or amphibians or reptiles or bees or plants that are either directly on a field or they're next to the field and they receive spray drift. For birds and for animals, we're generally focused on a dietary exposure, and then for bees, we'll also look at a contact exposure. A lot of, and then for aquatic assessments, our models simulate transport through drift and then through runoff into areas that are adjacent to a treated field or a treated orchard, and focus on potential risks there. As I said, a lot of our work is looking at listed, threatened, and endangered species, and we've been, looking at whether we need to expand our models or some of our assumptions, and I'll get into that a little bit more. Our risk assessments are tiered where they're kind of meant to be simple and conservative at the first cut. And the idea is that if you have a very conservative assessment and you don't identify risk concerns, then you can be confident that you don't have an issue with a given taxa. Whereas if the screen fails, then we would have to look a little bit harder. So let's refine our conservative assumptions. Maybe we ask for more data to try and refine that assessment and dig deeper. So the whole process is really built so that we can focus our time and energy where we think we need to, where it's a concern. And the approach is weight of evidence based, which we pull in different kinds of information, and I'll get more into that at the end. All of our approaches are based on peer-reviewed methods, models. So like I said, we go to a science advisory panel, or we try to pull up our models out of scientific literature when possible, or we'll work through a process of publishing our models. And we use our best available data, whether it's from the literature or from data submitted by pesticide companies that we review. There we go. Okay, so I'm not sure if you've seen this or not, but this is a kind of a schematic of the framework of an ecological risk assessment. So these assessments are all they're documents. They're for each pesticide active ingredient, we would do a risk assessment where we kind of lay out basically 4 sections. One is a problem formulation, and then we have a exposure and effects characterization, separate sections, and then a risk characterization, and these are typically available, publicly available on the docket. It, separate dockets are set up for active ingredients. Kind of as we go through this process, start out with a problem formulation at the top of this graph, where we kind of lay out what data we have, look at what fate data are generally telling us in terms of where the pesticide will end up in the environment, or whether they're of concern, and then we kind of lay out the plan for how we're going to assess the risks. In the exposure characterization, we run our simulation models and pull together any monitoring data that are available. And then for the ecological effects characterization, we would lay out the available toxicity data and describe kind of which taxa may have different types of effects, and whether we're really concerned about mortality, or is it some kind of more subtle effect on reproduction. And then in the risk characterization, we integrate everything. Now this is a kind of an iterative process where the scientists would work with risk managers, and as we get to a different kind of step in the process, we might go to the risk manager and say, okay, here's what we're seeing. We have these data gaps. Could we fulfill them with new studies, or are there any kind of mitigation options that you're interested in that we could perhaps consider? Like, could we put a spray drift buffer on the label, perhaps, and then investigate the impact on the risk that kind of mitigation might happen. So so we kind of try to go through an evolution as we do our risk assessment. All right.
Kris, how many more slides do you have here, just out of curiosity?
Oh, I've got, I think, 4 or 5 slides. Am I running late?
Yes.
Okay. All right, let me go quick then. Okay. All right, so in the exposure assessment, basically, I've covered some of this. We use, let me skip here. So we use exposure models that are empirically based. For spray drift, we use this model called ag drift that's based on a series of deposition studies that quantify the amount of the pesticide that's deposited at different distances from the edge of the field. And then we use those models to predict basically kind of what, if we don't have spray drift data specific to a pesticide, then we can use these models to predict the deposition off field. And then for tox, one thing I just want to point out here is the surrogate test species issue. So we typically have standardized species, and when we're thinking about butterflies, we don't have specific toxicity data for butterflies. We rely upon toxicity data for bees, for terrestrial invertebrates, and if there are data available in the literature, then we'll use it, we'll review it, and if it's suitable for our needs and it meets our validity criteria, then we'll use those data. But that's kind of an emerging area, is looking at relative toxicity of honeybees to other species of bees, like bumblebees. And then also, we've got a lot of questions about how butterflies, and different species of butterflies, may relate to the toxicity of a honeybee. And so that's kind of an area that we're starting to look at. We use there are a couple links down at the bottom of this slide. The last one basically defines our criteria for evaluating open literature. And so if a study that's published isn't very well characterized, or like if it doesn't describe the study design very well, or the test material, then we might not be able to use it. And so that's something that I tend to, kind of direct folks to do if they want to see what criteria we're going to use to evaluate literature. All right. And then for our risk assessment, basically we do kind of an RQ-based approach, risk quotient, where we take the estimated exposure either through diet or contact and divide it by a toxicity endpoint. For acute exposure, it's a mean lethal concentration or a no effect concentration for chronic. And then if the risk quotient is above a level of concern that's predetermined, then we would identify potential risk. Now this process is evolving for our national level consultations, where we're trying to consider more of a magnitude of effect, but this is our standard process that relies upon risk quotients. And so let me just skip to the last slide here. So when we do a risk assessment, it's not just the risk quotient itself that defines our kind of impression of whether a pesticide poses a risk. We also consider other factors like monitoring data or incident data. That can be a big thing where states or growers, folks will provide reports of incidents of mortality of birds or bees or fish, and that can influence, that can be an important aspect of our risk call. We look at field and lab data and try to see if that matches up, and a number of different pieces of information that may or may not be available to us. All right, and that was it.
Great, thank you so much. I'm given the time, and you're not in the room, so you can't see how we've sort of fallen. Well, you know we've already fallen behind schedule, but does anyone have a question they really feel like they need to ask, a clarifying or other question? Unfortunately, Kris, you're not here for our, hopefully, conversation later on. Anybody? There's one.
What would it take to get a caterpillar tested?
What would it take to get to caterpillar testing?
To have a caterpillar is one of the services.
To actually test caterpillars rather than just bees. Kris, can you answer that?
So, as far as a standard approach, it would take us going through kind of a process of evaluating kind of where our data gaps lie, and then trying to identify what data we need, and then standardize test methods for doing that, which is a multi-year process. So right now we're actually kind of, we started working on, just context, we started working on a bee methodology 2011, I think, and we've been working with other countries to develop test methodologies for larvae, and those methods are still being developed and standardized. So if there was, yeah.
Not bad. All right, thank you so much.